Hello and welcome to Calculus 2 here at Cañada College. My name is Lapuz. In this video we'll be doing checkpoint 6.14 from section 6.3. It says to find the Taylor series now for f of x is equal to 1 over 2x at x is equal to 2, and then after that find its interval of convergence. So we're gonna start off by building a Taylor polynomial. And hopefully we find a pattern. So let's take some derivatives. We have this, maybe I'll write this as a 1/2 x to the negative 1 power, so that'll make my derivative finding a little bit easier. So f prime is going to be a negative 1/2 x to the negative 2 power. Okay. And then after that, f prime of x, that's double prime of x, is going to be the 2 and the 1/2 and the negative would all cancel. This would just be x to the negative 3 power. And then the third derivative will be negative 3x to the negative 4 power. The fourth derivative, and by the time you get to 4 derivatives, instead of writing 4 primes, you just put 4 in parentheses to denote your fourth derivative, and this will be a positive 12x to the negative 5th power. Okay, just for the sake of being able to evaluate, I probably want to make it look a little bit nicer. This is a negative 1 over 2x squared in the denominator. This is 1 over x cubed. The next one is going to be a negative 3 over x to the 4th. And then the last one will be positive 12 over x to the 5th power. So now let's work on putting in our values. So f of 0, or I'm sorry, this is going to be an a, or center point at 2. F of 2 is going to be, let's put 2 in here. So this is 1 over 2 times 2, that's 1/4. F prime of 2 is going to be negative, this is 2 squared, so that's 1 over 2 times 4, that's negative 1/8. Next one, the second derivative. These are 2 derivatives evaluated at 2. 2 times 2 times 2 is 8. This time it's positive 1/8. The third derivative evaluated at 2. So we have 2 times 2, that's 8 times 2, which is 16, negative 3 over 16. And then the fourth derivative evaluated at 2 is going to give us a 12 divided by 32. I think that simplifies a little bit. Let's take a 4 out. Let's keep it as 12 over 32 because there might be some information there that will help us when we build our polynomial or series. Okay, so let's build our series. Your p of x, and hopefully we find a pattern here. We start off with 1/4, negative 1/8 x minus 2. And this is positive 1/8, but then we're dividing it by 2 factorial, which is just 2. And then we're going to multiply that by x minus 2 squared. And then we got a negative 3 over 16 divided by 2 times, 3 factorial, which is going to be 6. X minus 2 to the 3rd. And then the fourth one is going to be a positive 12 over 32 divided by 4 factorial, x minus 2 to the 4th power. Now let's put dot 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 here because I'm still not seeing a pattern. Okay. All right, so after we do that, let's see if we can simplify and find a pattern. We're going to get a 1/4 minus 1/8 x minus 2, and this I believe is going to be positive 1 over 16 x minus 2 quantity squared. And so if we cancel a 3 out here, and one of these 3 will be left with a 2 factorial, which is just 2, and then 16 times 2 in the denominator is going to give us a 32, so plus 1 over 32. This is also a negative, so let's put a negative sign here. And then x minus 2 to the third. And what happens here now? Let's see how things cancel. We can get rid of a 4 here and a 3 actually. 4 and a 3. There's a 4 and a 3 here, so 4 times 3. 4 times 3 is gone. That leaves us with 2, and then we have 2 times 32. 2 times 32 is 64, positive, and then x minus 2 to the fourth. And so you can see what's happening with the denominators here. It looks like it's just decreasing. We could do one more just to verify what's happening here. So let's try to generalize the f to the fifth. And we had a 3. We have a, first of all, this will be a negative, and then we have a 3, and then we have 3 times 4, and then we're going to have a 3 times 4 times 5 being multiplied together here, and this will be x to the negative 6 power. Okay, and then when we put that into the formula, and then we're going to put a 2 in here. So this is going to be negative 3 times 4 times 5 times 2 to the negative 6. So actually this would be down in the denominator, 2 to the positive 6 power. And then what we have in the denominator is the factorials as well. So we're at 5, so we'll 5 factorial, 5 times 3, 5 times 4 times 3 times 2. And we can see that these 3 things cancel, and then this is 2 to the 6th, and we add one more, so it becomes 2 to the 7th, right? And just to see what's happening here as well, this is 2 squared, this is 2 to the 3rd power, this is 2 to the 4th power, this is 2 to the 5th power, this is 2 to the 6th power, and then we just revealed that this next one, if we were to continue with the next one, it'll be 2 to the 7th power. So we kind of see that pattern there. All right, so we'll put the alternating part together. We'll put the power here increasing together, and let's see if we can write that up. So I'll put a dot 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 plus, and then it looks like we're guessing a negative 1 to the nth power, or maybe it's going to be n minus 1 or n plus 1. But we have 1 over. So in our 0th term, we start off with 2. In our 3rd term, we have 2 to the 5th in the denominator. So it looks like whatever term we're at, we are increasing by 2. The power of 2 is going to be 2 more than the power of the polynomial. So if this was x minus 2 to the nth power, this will be 2 to the n, and then we add 2 to it. And just to make sure, at the 0th, at n is equal to 0, we have a positive, and n is equal to 1, we have a negative, so it looks like it fits in, and we have a general formula now. Okay, so our power series, our polynomial, infinite polynomial, is going to be equal to that function. So our function is actually equal to the series as n goes from 0 to infinity of negative 1 to the n times 1 over 2 to the n plus 2 times x minus 2 to the nth power. All right, great. This is our series. Now that we have a series, let's actually figure out the interval of convergence. All right, so we'll go over here and find the interval of convergence. And to find the interval of convergence, we need to use the ratio test. All right, to find a ratio test, we're going to take the limit as n goes off to infinity. We're going to ignore the negative because we're going to need the absolute value. And then we'll have 1 over 2 to the n plus 1 plus 1. So we're looking at the n plus first term, so that's 2 to the n plus 2. X minus 2 to the n plus 1 all over 2 to the, oops, I'm sorry, that's 1 over 2 to the n plus 1, and then x minus 2 to the nth power. All right, let's see how that goes. So this is limit as n goes off to infinity. This will be a 2x minus 2. And the 1 over 2 to any power is just going to be positive, so I only need the absolute value around the x minus 2 here. I have 1 over 2 to the n plus 3. I'm sorry, this is plus 2 here, right? N plus 2. So 2 to the n plus 3 in the numerator and 1 over 2 to the n plus 2 in the denominator. So what does that turn out to be? This turns out to be 1 over 2 to the n plus 3 times 2 to the n plus 2 over 1. And so we got 1/2 left over. So all that just will equal to 1/2. And then from here, there's no more n's, so this is all independent, no more limit to take, so this is just going to be a 1/2 x minus 2. And then according to the ratio test, we want this to converge. We have to have this to be less than 1. All right. So if we have that less than 1, we're going to get x minus 2 will multiply by 2 on both sides, and it's positive, so the sign will remain, and this will be 2. And then this will look like negative 2 less than x minus 2 less than 2, and this will give us an x to be between, let's add 2 to both sides. This is 0, and this is 4. And that kind of makes sense because the center point is 2, and right now we know that we're going to go from 0 to 4 here, and our 2 is here, and we know that it's going to converge everywhere inside. Now we don't know exactly what happens at 0 and at 4, so we'll need to check that, but we do know it's going to diverge out here. Right, so we have the endpoints to check. Let's go look at our series again, and if we check the positive part, or the part that makes this positive, then we will get that alternating series test, or if we test the absolute value of it, then we will get it to converge for both sides, and then it'll be all good. We call it absolutely convergent or something like that. So let's test it. I think if we put 0 in there, we're going to get a negative 2 to the n times negative 1 to the n. That would make everything positive. So let's test this at 0. Let x equal to 0. So our series will look like series going from 0 to infinity of negative 1 to the n times 1 over 2 to the n plus 2 times x minus 2 to the n So again, these two will have the same power, and then this will be the series n goes from 0 to infinity of positive. So this is -1, this is a -2, so that becomes positive. It's like taking the absolute value, and then we have 2 to the n divided by 2 to the n plus 2. And I believe this will just be equal to, we got 2 to the n's can go away, and just sum of 1/4. Now, this looks like it's going to diverge, because you're just going to add 1/4 plus 1/4 plus 1/4, and it'll be 1/4 times infinity, so this is going to diverge. You can use the divergence test, limit as n goes to infinity 1/4 does not equal 0, so it's going to diverge. And I suppose that's the same thing that's going to happen with the alternating series. If this was 4 here, then it'd just be 2 to the n, and this would be alternating. So n goes from, so by the way, this is 0, we didn't get it to converge, so this will remain open. And if we put in 4, this will be -1 to the n times 1 over 2 to the n plus 2 times 4, or 2, I'm sorry, 4 minus 2 is 2, so that's 2 to the nth power. And the same thing's going to happen, except this is alternating. So n goes from 0 to infinity of an alternating series of just 1/4. Again, this limit here also goes off to infinity, so it's going to diverge as well. So both of these diverge. So we are not able to include any of the endpoints. The endpoints will also converge for us. Sorry, the endpoints will diverge for us, and so therefore the interval of convergence will be open, parentheses 0 to 4. All right, so I think that's it. By the way, this is a center point, and it's called the radius because it goes the same distance on either side, except we don't know what's happening at the endpoint. So it kind of looks like a radius. Technically, if we include real numbers, then you see the circle come out of there. In any case, we're just looking for the interval of convergence, and we found it to be open interval from 0 to 4. All right, I hope that helps. Good luck.